State consistency guarantees. Terraform state is not a backup file. It is Terraform's recorded understanding of infrastructure identity at a specific point in time. Every planned operation compares configuration against the stored record before Terraform decides whether resources should be created, updated, replaced, or destroyed. State consistency exists when the recorded infrastructure identity still matches the last successful provider write. If that record becomes stale, Terraform begins making decisions against outdated assumptions about ownership, dependencies, and remote object attributes. This is why state consistency is foundational to safe infrastructure automation. The planner can only produce reliable execution decisions when the stored infrastructure graph still reflects reality. Local state only protects consistency inside one machine and one working directory. The moment multiple engineers or CI pipelines operate against the same infrastructure, Terraform requires a shared state boundary so every operation reads from the same infrastructure record. A remote backend centralizes state reads and writes into one durable location. Each plan begins from the same infrastructure history. Each apply updates the same infrastructure record after successful provider operations complete. Without this shared memory model, two operators can make valid decisions from different historical snapshots. The infrastructure then diverges because each operation was planned from a different understanding of reality. Terraform protects state consistency by allowing only one state mutation operation at a time. Before Terraform performs an apply, import, state move, or state remove operation, it first attempts to acquire a lock against the shared state record. The lock prevents concurrent writers from mutating the same infrastructure graph simultaneously. Without serialization, two apply operations could calculate execution plans from the same starting state while independently modifying overlapping infrastructure objects. The danger is not only resource collision. Concurrent state mutation can corrupt dependency relationships, resource addresses, and recorded provider attributes inside the state graph itself. Locking protects the integrity of the infrastructure record before Terraform attempts to protect the infrastructure resources. Terraform does not track infrastructure by cloud name tags alone. It tracks infrastructure through state addresses that bind configuration objects to remote provider identities. A state address becomes the permanent identity path Terraform uses during future comparisons. If the configuration address changes without a corresponding state move operation, Terraform interprets the situation as one object disappearing and another object appearing. This behavior explains why renaming resources carelessly can trigger replacement plans even when the remote infrastructure itself never changed. Terraform is protecting graph identity consistency, not visual naming consistency. The infrastructure may still exist correctly inside AWS while simultaneously appearing structurally incorrect inside Terraform state. Terraform state consistency is strongest before execution begins and after execution successfully completes. The most dangerous period exists between those 2 points. Cloud infrastructure can be created successfully before Terraform finishes updating the shared state file. If the process crashes during that window, the provider object continues existing while the state record never captures ownership information. The next Terraform plan then evaluates infrastructure reality from an incomplete graph. Terraform may attempt to recreate resources that already exist because the infrastructure record never absorbed the previous successful provider operation. This is one of the most important hidden behaviors in Terraform operations. Infrastructure creation and state persistence are related operations, but they are not the same operation. On a submarine, valve positions are verified continuously because the crew operates from recorded system truths, not assumptions. If equipment changed position while the watch log remained stale, the next operator could execute a technically correct procedure against an incorrect system record. Terraform behaves similarly during state inconsistency windows. The infrastructure may already exist, while Terraform's operational record still believes the infrastructure does not exist. Terraform refresh operations exist because state consistency degrades over time as infrastructure changes outside Terraform control. Provider APIs become the verification layer Terraform uses to reconcile recorded state against current infrastructure reality. During refresh, Terraform reads remote object attributes and updates the state graph before calculating execution decisions. This process reduces the chance of planning against stale provider information, such as changed tags, deleted resources, modified attributes, or externally rotated values. Refresh does not guarantee infrastructure correctness. It guarantees that Terraform makes the decisions from the newest provider information it can retrieve before execution begins. Terraform therefore protects consistency through two separate mechanisms. State preserves historical infrastructure identity. Refresh verifies whether that historical identity understanding is still accurate.